let's increase the music. Mic check. Okay, again, I don't know how people got into here, but they did. So hello, there's 5 viewers and it's unlisted, so cool. But pretty much today we're going to look at the parabola, and I know we've looked at it before, but we're going to start going into a little bit more detail. So again, with the graphing, we're just kind of building on everything we know and going, like I said, a little bit further. So just like to recap, I guess, what we already know, I suppose, and it's that a straight line, kind of follows this. So it looks like y equals mx plus c. And so if we just recall, this was the gradient. So the bigger this was, actually maybe I'll draw it. Do I want to draw it? Yeah, okay, I'll draw it. Let's draw it. Y lessons, eh? Right, y equals mx plus c. And so then if I have, maybe I should have copied and pasted a few of these. Oh well. Okay, so y equals mx plus c looked like, I guess, that. Little arrows on the end. And we said that this value here was c, so like the y-intercept, and m was the gradient. And the gradient determined, I guess, how high or how low it was, and whether or not this was positive or negative also determined whether it was going up or down. So I guess if I were to actually make up an example, like y equals 2x plus 1, oh, y equals 2x plus 1, I'll move that over. That's not even a line, that is. So 2x plus 1 would kind of look like this, where that point there is 1, and the gradient of this line would be 2. So how could I draw that? I don't really know, maybe I'll go like that. That's 1 and that's 2. So like rise over 1, 2 over 1. Now if I had something like y equals minus a half x minus 1, something like that, then my graph would look like this. So it would be going, this tells me it's going downhill. It's also, that's the gradient of -1. Negative a half is going to be less steep, so kind of like that. But it's also going to cross at -1, so -1 is going to be down here, so it's going to kind of look like that. So if I just draw that, it looks like that. Okay, so that point there is -1. It's negative, so that tells me downhill. And I guess the half, so the rise over run, so the run would be 2, the run would be 1. Okay, so rise, run, rise, run. Now, the reason I'm starting parabolas by looking at straight lines is because we can use the equations to kind of think about what's going to happen to each of them. So at the moment, all we're going to look at is moving one up and down, and that's all we ever looked at when we looked at lines. So if you think of a line as this thing, yeah, okay, it goes up and down, like it goes the gradient steeper and less steep and stuff like that. But at the end of the day, this value here is just moving the thing up and down. We're never actually moving it left and right. So you increase this, it goes up. You decrease this, it goes down. It's going up and down, and that's literally, I guess, all you can do to talk about a straight line. Now, if you were to rearrange this and solve it for x, and then you'd have a value here, this plus c on the end of this would actually move it left and right. So we're going to look at that next lesson, but today all I really care about is y equals something, and then with the plus c that moves it up and down. That's all I care. I keep looking at it, the camera's up there. So with a parabola, and you've seen this before, so y equals x squared. Okay, if I just draw my quick graph, but y equals x squared, I know that it looks like this. So I know that, I didn't want it to be that thick. I know that it looks like that. So I always relate, I guess, translation, the music do be loud. Really? Okay. Oops. Okay. So I always try and relate modifications to a graph to the original thing. So in other words, like with this, I always just start with y equals x, which is it's just a straight line, cuts through the origin, has a gradient of 1, and then I start changing it. So it changes by the gradient, so either that or something, and then it goes up and down. So you just got to think about all the things that happen to it, and it's the same with the parabola. So y equals x squared, it's what I've got up here in the top corner of your screen. That's y equals x squared. The second I change, so I guess, let me move this and make another one. Copy, paste. We can kind of do the exact same thing. So here we've got something that changes how steep it is and something that moves it up and down. Same thing here. I'm just going to put something here that changes how steep it is. So steep / gradient. And then I'm going to add something that changes it moving up and down. So this makes it go up and down. Okay, so you've got your normal graph, which is this. If I have an A in front of it, so let's suppose that's 2, it's going to make it steeper. So steeper means that the graph's going to look a little bit like that. And if I add a value on there, so I guess maybe 1, see how the y value here is 0? Well, if I made it this 1, then it would actually be here and it would be up like that. So it's called a translation. A translation means I'm moving my graph. So I'm going to be moving my graph. So let's go over some examples. Let's suppose I've got y equals, I don't know, what are the ones the textbook uses? Do I care about that? No, maybe not. Let's go with 3x squared minus 1. So you can see that this and this are exactly the same, except I don't use m, I use a. So it doesn't really matter, you can use a m if you want. And then there's still a plus c on the end, it just moves it up and down, the same thing. So if I've got something like this, okay, so I just relate it to the graph I had before. So I'm going to relate it to this. Now I'm going to draw it. This 3 here tells me that's going to be skinnier. So I'm going to draw it skinnier than this. So maybe I'll draw, do I want to draw the original? No. Yeah, I'll draw the original on there. So the original will look like this. Those arrows are going to be annoying. So that's the original. Now if I draw the modified one with that and that, it's going to now, instead of being here, the y-intercept is going to be -1. So that's the y-intercept, which is going to be here. Let's call that -1. That 3 is going to make it skinnier. So make sure it's heat skinnier than the original one. And that's enough for a sketch. All I want you to be able to do today is tell me, like, be able to, I guess, identify which graphs are what, essentially. Okay, so that's my y-intercept. Let me move that so I can do another one. Let's go y equals -2x plus 3. Let's do that. Let me move that. So if I would draw another graph. Now, again, I'm relating it to the original. So that one is the original. The original is going to be, so what am I trying to draw? Let's think about this. The original looks like this. This -2 tells me it's skinnier, so it's skinnier. This negative here tells me it's going to be upside down, so it's actually going to be like this. And that +3 tells me it's going to go up 3. So it's going to be up there at 3, and it'll look like that. So let's go through that. That's going to be skinny / steeper. You know how else you want to think about that. That tells me it's going to be upside down. And that tells me it's going to be up 3, or have a y-intercept of 3. So y-intercept at 3, I always draw that first. So that's going to be 3. It's going to be upside down and a little bit skinnier. It should be less skinny than this 3 one though. So maybe like that. And that's enough. My graphs don't look great, but I'm sure you're better drawers than I am. All right, let's do one more. Y equals, let's go a half. Oh, I haven't put a squared there. A half x squared plus 2, something like that. Okay. So we'll go like this. Now, actually, let's not make this 1 on 2. Let's make this 1 on 9. So 1 on 9. Okay. Now, this tells me, let's actually write it. This tells me it's going to be, instead of being steep, it's going to be really wide. So if you think of, if that was just 9, it would be like this pretty much. 1 on 9 tells me instead of looking like this, it's going to probably look like that, something like that. But it also has to go up 2. So that's going to go up 2. So it'll just start there and be really wide. And that's 2. I should probably label my axes, but I have not done that, so oops. Okay, and I guess that's really all we need to know. So translating a parabola upside down means I have ax squared and I have this plus c on the end. Next lesson we're going to look at moving it left and right. I'll show you what that means. But yeah, I just want to show you 2 examples because it's all well and good to be able to identify them, but you need to be able to, I guess, identify features of them as well. So for for the graph of the given quadratic equations, so that's each of these, state whether the parabola is wider or narrower than the graph of y equals x squared. So remember, y equals x squared is just the original. So if I just look at A, so y equals x squared minus 1. Now it's going to be, so for I, this value here tells me it's going to be skinnier. So it's going to be narrower, is the word they use, so narrower. Now it asks me, has it been moved up or down? Well, it's actually been moved down 1, so down 1. Or you could just write minus 1. And then the y-intercept, well, the y-intercept is that. So it is y equals minus 1. That is the y-intercept. Okay, B. B is 1 on 3 x squared plus 2. Okay, this tells me that it's wider, so it's going to look like that. It's going to be wider. It's has it been moved up or down? Well, it's been moved up by 2. And what's a new y-intercept? Well, y equals 2. And that's it. Oh, one other thing I want to show you. With each of these, you might be asked what the axis of symmetry is. Now, the axis of symmetry just means I cut the parabola in half. So obviously that's just going to be here. The axis of symmetry is there. And for this one, it's also here because that cuts it in half. It's also here, it's also here, it's also here. So in this exercise, when they ask you that, you're literally just going to be like, well, I'm only moving it up and down, I'm not moving it left and right. So the axis of symmetry is never going to change. But what you do need to be able to do is identify certain points on the graph. So the question might say, oh, okay, if x equals 5, so I suppose that's 5. What's the y value? And in this case, the y value will be down here somewhere. But you're just going to be confident in answering that. And it just comes down to remembering that this is an equation. And when it's asking you for a point on the parabola, that doesn't mean draw the graph. That means, look, it's told me what a y coordinate is. I have an equation that has y in it. Use my equation. If I have the equation, use it. So just use your starting point of this graph. It's asking me find the x coordinate. So that means x equals, well, I don't know, that's what I'm trying to find. But it's got a y coordinate of 191. So that means y equals 191. So I can use my equation now. So 191 equals 3x squared minus 1. And you might have thought back when we were doing equations, why would I ever need to solve something like this? Here we are. Now let's do this properly. I'm going to add 1, so that's going to give me 192 equals 3x squared. I'm going to divide by 3, Actually, I don't know what 192 divided by 3 is. 192 divided by 3 is 64. So that tells me that 64 equals x squared. And it's x equals plus or minus the square root of 64. So that means plus or minus 8. Okay. Now I want you to think about this a little bit. I've got 2 answers here, and the reason we keep our plus minus is because of this. Let me draw what this looks like. 3x squared is skinny and down 1. Skinny, oh geez, what has happened there? It's skinny, oh my god. Okay, skinny and down 1, let's call that that. So that's 3x squared minus 1. Let's do this properly. That's a y. What's next? Now, it's asking me for a y coordinate of 191. Let's call that 191. Okay. Why do I have 2 answers? Well, at this y value here, I have 2 x values, there and there. And because it's symmetrical or has an axis of symmetry over this, it's going to be plus and minus 8. So in other words, this here is going to be the point 8, 191, and this point is going to be minus 8, 191. So keeping up plus and minus actually makes sense, and there's a reason we do it, and it's because if I just said to you, or if I just asked you, okay, here's 191, what's my x value? Well, cool, that's one of them, but you haven't actually told me what this is. So anytime that you forget a plus minus, you're actually forgetting a point on the graph. That's what's actually happening. Yeah, I feel like that's all I want to say about that. If we move over to our little graph over here, I'll just convince you that what we were looking at before is true. So if you see up there it says y equals x squared, if I change this a value, so that's the one that's next to the x squared, so looking at this one, so when you change a, you make it bigger, it makes it steeper. So we had an example before where it was like 3, so it's a little bit steeper. When it's 1 on 9, so when it's like a fraction, or 0.6 or whatever, it's thicker. And our c value, which is the value that's going to be added on the end, if you increase that, it goes up. If you decrease that, it goes down. If you make a negative, then it's going to be upside down. So I guess if you wanted to play with that to check your answers and stuff, you could. But that's pretty much it when it comes to translating parabolas up and down. 16 minutes, well.